Mark, Sebastian, and Paige Bailey from Google are going to lead a discussion about LLM strategy and career perspectives. Woohoo! Take it away.
All right, appreciate you, Beverly. Morning, everyone. So, in inviting folks to the conference to speak, I'm a big fan of both Paige and Sebastian. So to start off the discussion, what are you most excited about with LLMs and Gen AI?
Excellent. Well, thank you so much for having us here. I'm a big fan of y'all too, and big fan of Atlanta. So very excited to have the chance to come back and to get to talk to y'all this week as well. I think from my personal perspective, the thing that I'm most excited about for large language models and for generative AI in the next couple of years is some of the work that we've been driving at DeepMind around machine learning for software development, and then also giving models the ability to generate code to interact directly with APIs, with extensions, and with existing systems. So what this means from kind of like a legacy software perspective is think of how awesome it would be if you would never have to write all of the code to do software migrations again. If you wanted to upgrade from one API to another, or you wanted to migrate from COBOL to Java, or COBOL to a language that's a little bit less painful than Java, then having the ability to do that with just kind of running a model and making those changes, or being able to generate in natural language an Excel function or macro that you would like to have, or a connection to a database, and have the code automatically created for you, even if it's something like a proprietary language. So I feel like we've been really sort of testing the boundaries of using large language models to create things in the past, half year. And now we're starting to explore the ways that large language models can help us maintain those software systems over time. And I think that's truly a trillions of dollar opportunity in the sense that everybody likes to build stuff, but nobody really likes to do maintenance. And so if we can make that a little bit more pleasant, that would be a really exciting time.
Will we still get calls late at night to fix things?
I still am on pager duty, pun intended. Like there's actually a Go link within my company that's Go/pager duty, and it just like sends a text to my phone.
Sebastian, what are you most excited about?
This still works. So what I'm excited about is, I would say more from a selfish perspective, how exciting or interesting it is to work with large language models. Like I mentioned before in my talk, like it revitalized the open source systems, and everyone is contributing. It's actually a very exciting time to be a tinkerer and to try these systems out. I was in statistics before. I was working on relatively, I would say comparatively complicated models, and it's actually surprisingly simple to work with LLMs or transformers. The architecture is actually not too complicated, and it's just a lot of fun to work with this. And I'm also very excited about the recent research on parameter-efficient LLMs, making these models more efficient. I would say it's maybe more selfish, but it's just so exciting to be working on these problems, and also to see the open source community working on collaborating and building systems together. And that is my take on this, essentially, in addition to, of course, the applications in the real world.
Fantastic. So Sebastian, the field of machine learning is moving quite fast. There are many folks in the room who either run teams, they're on teams, they may be building teams. How should they be thinking about their education culture for their teams?
Yeah, it is moving incredibly fast. If you remember this one slide I showed you where there was the code llama model, and then 2, 3, 4 days later, there were already like 3 or 4 open source models on top of that. So yeah, it is a bit hard to, let's say, keep up every day. It can be a full-time job just keeping up if you want it to be. But fundamentally, I think it's if you keep an eye on things, it would be hard to miss the trends. You don't really have to micromanage your day and keep up with everything. There is so much, let's say, good material out there, and it's essentially a balance between doing things yourself and observing what other people are doing. And I think it can be stressful if you let it, but it's just fine if you take some inspiration, update your systems once in a while. keep a bit up with things. And also it's surprisingly related to, so the topics are surprisingly similar. So once you get a good hang of the basic transformer and GPT architecture, you will see that something like Llama is very similar. There are a few tweaks in the layer norm and stuff like that, like little details, but the fundamental concepts are so similar that if you understand one thing, it's very easy to transfer it to the new thing. So in that sense, it's actually not as bad as you might think to keep up with things.
Yeah, I 100% agree. And I've also been really enchanted to see the explosion of open source models in the large language models and generative model space. One thing that's been really, really helpful for all of the engineers and kind of the PMs, even program managers that we have at Alphabet is just testing out the models. Right now, these APIs have made everything so accessible that even if you're not a programmer, even if you don't want to create a custom version of a model or do continued pre-training or fine-tuning, you can just kind of use many of these things out of the box to accelerate your workflows, to make them more productive. And one of the things that's been most exciting is seeing these people who don't have a programming background whatsoever, but they do have a lot of ideas about how they could make their systems more efficient or build new things, and just kind of getting in there and testing them out with tools like Hugging Face or some of the playgrounds around these APIs. So I think you can build a lot of intuition that way. Even if you don't necessarily want to train models yourself, you can use the models that other folks have trained to do a broad variety of tasks. And since many of them are now open source, you can also get an idea of the kind of underlying data that was used to train them, and even kind of suggest additional data sets that are like, oh, well, I really care about SQL, or I really care about Excel functions, or I really care about certain kinds of languages. Maybe it's C# or .NET or whatever it might be, and making sure that the models get trained on preferentially more data, which would make them better at those tasks downstream.
Great. So Paige, what industry use cases have you seen LLMs and Gen AI work really well for, and which ones have a way to go?
That's a great question. So I'm not sure if folks saw, but at I/O we recently released a model called Palm 2. I was the product lead for Palm 2. It's the model that's now kind of supporting most of Alphabet's generative AI deployments across the company. Everything from code assistance tools, so being able to generate more effective code, explain code, help with debugging, help with security vulnerability detection, help summarize errors or logs, to things like helping you write emails, helping you write better documentation or better design docs, all sorts of things. And I think one of the places where we really need to work a lot harder as an industry is on, as the previous speaker was mentioning, things like responsible AI, making sure that these models have the right gate checks in place for toxicity and compliance, but then also finding clever ways to ground them. So helping with factuality. If you have a model that's generating source code, maybe it would make sense to kind of supply API documentation for the kinds of code that you're trying to build. Because just like a human, if you show a human some API docs, they're probably going to be much better at accomplishing a code task. So just getting a little bit more diligence around retrieval techniques, around incorporating more information into the context window for models, and then also helping have these verification systems in place such that if you are getting an output from a model, you have some idea or some notion as to whether that output is actually valid.
Great. So I typically like to think to myself, I have the privilege of working at NVIDIA, especially now. And one of the things I've observed, as you look at your data science career, I've looked at the 1% of data scientists, or the 0.01%. It's very similar to the wealth curve in the world. The 0.01 or 1% of data scientists, what I think separates them from a lot of the other data scientists is this skill of distributed training. So Sebastian, I wanted to ask, since you're doing a lot of stuff at Lightning AI, how should teams be thinking about distributed training? I know maybe if folks launch 2 or 3 or 8 GPUs, it's sometimes a big deal. Internally, we launch thousands of GPUs every day. We make them, but still, we can't even get our own things sometimes. What's your thoughts on teams getting started with distributed training?
Yeah, that is a good question, because I remember not too long ago when I was in academia doing research, I was just doing I was training one model per GPU because that was the easy thing to do. And it was possible because it was like ResNets and small types of neural networks. And yeah, even though I had, I don't know, like dozens of GPUs, I was just training one configuration per GPU, doing hyperparameter tuning that way. I never really did multi-GPU training until I would say 2 years ago. So there were these different strategies in Python, PyTorch, data parallelism, distributed data parallelism. And data parallelism was pretty easy to set up. It had some disadvantages with distributed data parallelism. It got a bit trickier where you are using multiple machines that communicate with each other. And I remember it was just this summer, I was just writing from a tutorial perspective how to set that up. It was a lot of code, a lot of work, just to have a simple example. So going from one GPU to this distributed setting, it required at least 20 or 30 lines of code changes, an additional function here and there. And it's not something you can then easily switch between one and multiple GPUs. At Lightning, we have an open source library called PyTorch Lightning, and there's also Fabric, which is essentially a wrapper around all of these. So you can technically, with 2 or 3 lines of code, I have one line there, and you can specify the devices and the strategy. You can use a fully sharded data parallelism, deep speed, colossal AI, and so forth, all of these strategies. And with one line of code, you can just toggle between one machine, 4 GPUs, 4 nodes in a cluster, and 4 GPUs each, whatever you have available. And yeah, the key nowadays is really, so I showed you in my slide a few examples where you can train a 7 billion model, parameter model, 7 billion parameter model like Llama on one GPU if you use LoRa and so forth. But if you want to scale it up to 7 billion, you would eventually have to use 4 or 8 GPUs or even more. But again, with these 1 or 2 lines of code changes, it's really easy these days. And they do things not only like distributed data parallelism, but you also have tensor sharding, which is very important because distributed data parallelism, what it does, it's sharding the mini batches into micro batches, so sharding the data. But nowadays, these large language models are so big that the matrix multiplication is just too big for a single GPU, so you have to also divide the weights and put them on different devices. And yeah, again, it used to be really hard, but with open source libraries, 1 or 2 lines of code, they are wrapped around that, and it's just seamless. So you can just toggle it between whatever hardware you have. And I think this should not be a bottleneck anymore if you have multiple GPUs.
It's the same for the JAX, which is an open source library that Google created, and strong +1, having as much guesswork about distribution taken out of the equation for the people who are creating the models and creating the systems really kind of empowers people to build more effective, more creative models. And to not spend all of their time trying to debug configs as to why, if I'm spreading across 8 H100s or 8 A100s or 8 whatever it might be, how do I just kind of have the shortest path towards having an idea to actually implementing it?
Yep. And one thing for just folks in the room, anytime you go into a distributed training strategy and you think about cost, a significant factor in your cost is networking and storage. It's not actually your GPU. So as you think about, I'm going to build an on-prem cluster, I'm going to use things in the cloud, those are the things that you sort of want to keep in mind. All right, Paige, you lead teams at the forefront of productionalizing LLMs and Gen AI. Other than reading Sebastian's fantastic newsletter, I highly recommend everyone to. I'm giving him his plug.
And following his Twitter.
Yes, and following his Twitter. So increase his Twitter count by, I think, 200 by the end of this talk. How should teams and individuals think about approaching their implementation of state-of-the-art models?
So I think that's a question that will differ based on organization's level of maturity and then also the kinds of use cases that you're trying to tackle. Because at the end of the day, if we're talking about productionalizing AI, it's really about like solving user problems. That's the thing that we should be most focused on. Not necessarily deploying the biggest model possible, though I know that can be cool, but actually having a fit for purpose model that can solve the task that you need it to do in a way that's also efficient from a cost perspective. So one of the coolest things about this release recently of open source models is that I think it's unlocked within all of our brains this understanding that you don't need a 64 billion or 68 billion parameter model in order to do interesting things. We're already seeing that 7 billion, 13 billion parameter models, which can fit on a single GPU for inference or something similar, can fit on your laptop in some cases. They can, accomplish things that most of us would have never imagined, either through additional fine tuning or just kind of out of the box. So I think from a business perspective, you should also always balance, like, do I want to have an open source model and spin up that infrastructure myself? Do I want to leverage a REST API that a company has created? So either OpenAI or Microsoft or Google or any of the other many solutions that happen to exist today. Hugging Face has also started offering inference solutions. Or do I want to try to kind of push the boundaries and train bigger models myself? Because I think, at the beginning of this AI gold rush, because it is very much a gold rush, or it feels like it, which is a little bit overwhelming as like people who have been doing machine learning for a while. People kind of were like, all right, well, I'm going to train my own foundation model. And then everybody kind of looked at the price tags and they were like, maybe not. And now there's a lot of interest in kind of taking off-the-shelf models that are very powerful or just using REST APIs, either through like perhaps a little bit of fine-tuning to have something more catered to your needs.
Great. So a question for both of you. How can the average data scientist get more experience with state-of-the-art models when they don't have access to large compute?
It goes also back to the parameter-efficient techniques I mentioned, where using these open source libraries, you can technically train it on one GPU if you consider the 7 billion parameter models. And if you think about this NeurIPS competition I mentioned, the LLM efficiency challenge, it is essentially restricted to a single GPU for 24 hours. So in that case, this would be a good test bed, and also keeping an eye on what other people are doing there. And there are lots of techniques that you can actually use if you only have one GPU. And I think, for example, Google Colab, I think the Pro version, which is a small subscription fee, you can already get, I think, A100 there, for example. And so I think there's nowadays not a big, nothing big that holds you back, unless, let's say, you want to use really the largest models. But I think for most use cases, that's not necessary. And also, to give one example is, back in the day, I worked or collaborated a lot with people in social sciences who were really interested in prediction, like email classification and so forth for certain studies. And we trained a lot of different models there. Always were getting, limited, let's say, performance in terms of classification accuracy. You can actually train a Distilbert model even on a laptop. If you consider the 50,000 examples from the IMDb movie review database, you can get 93, 94% classification accuracy just by training it for a few hours on a laptop, which is actually amazing. So you don't necessarily even need a big computer to leverage that. Also with vision transformers, Cypher 10, you can use the smallest vision transformer in PyTorch to get 95% prediction accuracy on Cypher 10 without spending tons of money. You can do that in 60 minutes on a single GPU these days, which is really incredible. So I think there's a lot of stuff you can do even if you have limited resources.
Absolutely. I was going to plug Collab Pro, but you beat me to it. Definitely want to highlight the importance of work with what you can. And there are places to get a single GPU. So Collab Pro and Pro Plus is a great example. You could also just, if you have a laptop that does have a GPU, the GPUs in MacBook Pros are pretty powerful these days. You can probably do a lot of work, like the Llama CPP. The Llama CPP examples were showing quite a bit of promise there. So definitely work with what you can. You can build a lot of perspective just using a single GPU. And then also, if you're curious about which model you should try out or which model might be best for your use case, just testing out on something like Hugging Face is not a bad solution. If you want to understand of the many, as an example, code generation models, which might be best suited for your team, feel free to test it out in one of the UIs, and then once you've kind of solidified on, yes, this seems like it would be the most promising approach, then move towards trying it out in an actual notebook. So again, I'm a huge fan of the idea of reducing the amount of time that it takes from having an idea to doing something with it. And I feel like oftentimes there's this real apprehension of like, oh, if I want to try anything with machine learning, then I have to download all of these things. I have to get my environment ready. I have to start training. When the reality is now there are a lot of tools at our disposal to make that process a lot less painful.
Perfect, because I think as we get closer to the end, I personally we snuck through Khalifa to get to you. Invited you both to come here because I've observed your careers from afar and I've admired both of your career trajectories. What's been your career optimization function? Is it wealth? Is it brand building? Is it expertise? What has it been for you? Well, actually, both of you, yeah.
I would say just following my curiosity and working on things I'm excited about, and then the rest comes by itself, I guess. Just as an example, I was in academia for a long time and I really liked it. The only thing I did not like was, the peer review system where you sometimes get upset because someone said or commented on something that you didn't agree with, but then, you had to do certain things you didn't want, and I felt like, okay, that didn't make me happy, it made me upset, so maybe that's not the thing I want to do. And now I'm working on coding on things I like, I enjoy. And yeah, that's really for me, like to figure out what do I like doing. If you're motivated to work on something, I think the success or whatever you want comes with it. If you are excited about what you're doing, in my opinion.
Absolutely. I love the idea of following your curiosity. And personally, in my career, there are some ideas that very much excite me. So my background was geophysics and applied math. And if any folks have experience with the oil and gas industry, you know that the only place to find that kind of data would be at a Chevron or a Shell or a BP or an Exxon or something similar. So I actually started doing machine learning and data science working there. And if you have this perspective of go where you'll learn the most, go where the opportunities are, which are really completely concentrated these days on the data, then it helps make all of the other decisions really straightforward. And there have been moments in my career where I either move job locations or I change a role description as a result of sort of going to the place where I would learn the most and going to the place where I would be able to do the kind of work that I find most compelling or the most interesting or the most promising. And it's never been a bad choice. Like if you go where the data is, if you go where you'll learn the most, then you're always making the right decision.
Fantastic. So I guess I'll open the floor for questions for anyone. Oh, we have a question up front. I would jump off the stage, but Beverly, I might beat you to it.
Thanks, Khalifa.
Thank you, appreciate it. This has been wonderful. Thank you, guys. The question is more about, with LLMs, there's, productionalizing models that we've done with tabular data, and, you can draw parallels with LLMs, right? So what are considerations that we need to think about when we're implementing LLMs for critical applications? Like, with tabular data, there's context around, drift, about confidence of the predictions, about accuracy, and also about like bias and fairness. So what are parallels to LLMs, and, where are we in that, and what are your thoughts about that? Thank you.
So one thing, that's a great question, by the way. And for folks in the audience who might not have heard, it was around the considerations for deploying large language models in production. Not just financial considerations or latency considerations, but also things about how, since the outputs are not deterministic, how do you implement them with some sort of confidence that that they'll actually be doing the thing that you need them to do. And one of the places where we found machine learning to be most valuable for Alphabet internally is in our software systems. So doing things like code generation, code explanation, but also things like automating code review and finding performance fixes. So looking fleet-wide across all of the compute that Alphabet has, which is quite a lot, and then seeing places where you can make a small code change, but it realizes something like $300 million of savings each year. But the important piece for those kinds of things was this understanding that a human should always be in the loop. It's kind of like having a fleet of grad students to do your bidding. And you might ask them to come up with summaries or to run some analyses, but you're probably always going to be quality checking their work. And so considering them as kind of like your junior SWE helpers, or something that you should kind of do an extra last minute step to verify before actually deploying or using in full has been really, really important for us, these HCI considerations.
Yeah, and on top of that, I would echo exactly that. It's also, in my talk, I had this example of Bloomberg GPT, where they trained their own model on finance data. And one of the tasks was, for example, generating this Bloomberg query language, and the other one was generating news headlines. And here the deployment, it could be a deployment internally, where then the employees could use the system to generate the headlines, but this should not literally be the headline that the news article has then in the end. There is some person in between who can then choose and tweak it. So it's not like, the end result. It's really a step to get to the result more efficiently, I would say. And the other one is also related to this retrieval augmented generation, where you don't have to have the LLM generate the whole response. You could have these vector database approaches where you pull something from a code base or database, and then again you might have to check it. But it's really the trade-off between, is this better than having nothing, and if also it's just internally and not the end step, you can also minimize risk that way. It's really it can be tricky, but there can be a lot of value in that.
It's also interesting how much this is similar to the other production deployment scenarios that we've seen in the health sciences and in the oil and gas industry and a couple of others. In that in the healthcare industry, if there is spotting something that could perhaps be a tumor, perhaps be something cancerous in an X-ray, it's not just like immediately sent to the patient, being like, "Hey, guess what?" It's sent to a medical professional, who then has to kind of use their knowledge and their expertise to say, like, yes, actually, or no, perhaps we should get some additional opinions. So I do love this idea of, this is assistance for the subject matter experts. So we're always going to need subject matter experts, but it's helping them be more productive and accelerating the number of cases that they can do each day.
Perfect. Beverly, I think, are we on time?
Yep, we are. We're
All right.
doing great. So thank you guys so much.